So in this video, I am going to discuss about dual simplex method. So dual simplex method, it is a specialized form of simplex method in which optimality is maintained in all the iterations. So it means we don't need negative. So if we have negative, that's what we call infeasibility. Next is initially the solution may not be feasible. Successive iterations will remove the infeasibility. If the problem is feasible in an iteration, then the procedure will be stopped because the solution already obtained the feasible and optimal at that stage. So in this problem, if we already got all positives, it means we already reached the optimality, or it means this is already a feasible solution. So now let's start. The problem here is solve the following linear programming problem using dual simplex method. So here minimization z is equal to a plus 2b plus 3c. Our constraints 2a minus b plus c greater than equal to 4. Then next, a plus b plus 2c is less than or equal to 8. Next is b minus c greater than equal to. So a, b, and c must be greater than or equal to 0. So first, we need to step 1, we need to convert the constraints 1 and 2. Why? It's because it is greater than or equal to 4. We will convert it into less than equal to by multiplying in negative 1. So let's do it. Subject to a this one 2a, it must be negative because we will multiply it into minus 1, negative 1 rather. So negative 2a plus b, since this one is minus, negative 1 multiplied by negative b is equal to positive b, and then negative c, and then less than equal to negative 4. Next, this one as is, it's because it is already in a less than or equal to a plus b plus 2c less than equal to 8. Next, this should be changed. Negative b plus c less than equal to 2. So a, b, c. Alright, so let's move. So we already converted 8. So next, we need to add slack variable in each constraints. So, how we will do that? Okay, so we will add slack variable. Minimization z a plus 2b plus 3c. And then subject to constraints, subject to, we have negative 2a plus b negative c is equal to 4. Negative 4. Next, a plus b plus 2c is equal to 8. Negative b plus c is equal to 2. So, it will be negative 2a plus b negative c plus slack 1. This will be slack variable 1 equals negative 4. And then a plus b plus 2c plus s2 slack variable 2 equals 8. Next, negative b plus c is equal to s3. Equal to 2 rather. This could be plus. Negative 2. Okay. Next, let's move on to iteration 1. So, iteration 1. Alright, so this is our iteration 1. 1. Right. So we will put all the variable here. Our objective function Cj is the objective function 1a plus 2b plus 3c, and then we added the slack variable. We have 3 slack variables, and then we will put the constraints here. We have 3 constraints, so we just put in here. We have negative 2, 1, and then negative 1. Next, we have slack variable 1. We just put 1, and then slack variable 2, 0, because in constraints 1 we just only have 1 slack variable is equal to negative 4. Next, 1, 1, 2, 0, 1, 0, equal to 8. We just put 0 since we don't have a value of a. 0, -1, 1, 0, 0, 1 is equal to -2. Now let's compute the zj. Zj is 0 into -2 plus 0 into 1 plus 0 into 0 is equal to 0. So continue, 0 into 1, 0 into 1, 0 into 1, and then after that you just add. The answer is 0. Next, 0 into -1, 0 plus 0 into 2 plus 0 into -1 is 0. So just put that 0. Next, we will get the Cj minus Zj. So Cj, 1 minus 0 is 1, 2 minus 0, 2, 3 minus 0, 3, 0, 0, 0, and 0. Okay, so looking at the solution, we need to determine the higher negative value. So higher negative value, it means that will be our leaving variable. So which one is higher negative value? So we have two negatives here, the -4 and then -2. So the higher negative value is -4. So we will encircle this one. This will be our leaving variable. S1 is our leaving variable. Okay, S1 is our leaving variable. Next, before that, since we are using the duality, we already have the key row. This one is key row. So how we will get the key column? First, we need to get the ratio of Cj minus Zj between Cj minus Zj and S1. So how? We have the determination of entering variable. So in here, we have the variables A, B, C, S1, S2, S3, and then negative Cj minus Zj. So we will just copy Cj, -1, -2, -3. This will be the determination of entering variable. Alright, then we will put the S1. So we will just copy the value of S1. So in here we have 0, -1, here, S1 rather, S1, -2, 1, -1, and 1. We will just copy as is in here. -2, 1, -1, 1, 0, and 0. So we will just divide to get the ratio. So -1 divided by -2 is equal to 0.5. -2 divided by 1. Okay, in getting the ratio, we need to ignore the positive values or the zeros in the denominator. So since this one is positive in the denominator, so we just ignore it. Okay, we just put dash, means ignored already. So after finding the ratio, find the least value. So the least value, that will be our entering variable. So this one, negative 3 divided by negative 1 is equal to 3. We have positive, ignore, 0, ignore, ignore. So let's find the least value, which